Welcome everyone. We are looking at the BBC Micro basic language again. Where we left off, I think, was here. Now we're getting into the interesting stuff because there are commands in BBC Basic that you won't find anywhere else on 8-bit computers. I don't think. I may be wrong, but definitely old for one. Yeah, old. I don't know if that works here. Nah. It works when you put the coprocessor in because it brings back the tester. I know that for a fact. I've been playing with it. Who is it? Ah, dear. Hello, Stacy. Right, so this is one of the commands that you won't find in Commodore Basic. I don't think you can find it in Sinclair Basic, which is the repeat until. And the way this works, so we'll copy this. Paste it in there. The way this works, it will repeat between the repeat and the until. So anything in between there, it will repeat until this has been satisfied. So basically this is going to run through this for what, 100? A million times. How do I do? Don't know, mate. Were the square brackets in there in the keyboard? Oh, so it was. All right, so it must be. It must be oh, this is my font, isn't it? This is my font. This is the font I use for all my for my branding. Stole it. I didn't steal it. This is oh, so that's where the name comes from. Oh, that's where the name comes from. There you go, mode 9. That's my regular. See if it looks the same. Ooh. Yep, it's the same. That is my font. Well, I never knew that. Because when I do square brackets in CBM, it comes out as the arrows. Well, well. Never mind. Right. Back to repeat until. So, repeat until, it will loop between the repeat and the until lots of untils. Until that expression until the expressions run. So if we run it, there you go. So it ran 20 times before x became above 1,000,000, and it was doubling x every time. So that's 22 to the power 20? Nah. 20. No. Yeah. 2, 4, 8, 16, 32. Yeah. So that's 20 bits. So that would equal that. So that's how repeat until works. And this was not on any... Well, it definitely wasn't on Commodore Basic, because you had to do the 4NX. Now, so here's a game. Simple text game. Let's bring it in. Yeah, but MS Spec... What, the BASIC that was on 8-bit machines before GW BASIC came along, did they use WauloK? Because I know it was in... I know it was in Q BASIC. Was it in GW BASIC? Yeah. So it was in Q BASIC, not GW BASIC, because GW BASIC was similar to the BASIC that sold all the 8-bit machines, wasn't it? Right, so this, how many times, see how many sums you can do in 15 seconds. Alright, well I've blown that one. Oh, hang on. Three in 15 seconds. Wow. So they're doing the repeat until for time minus what the start time was is greater than 1500 ticks. Let's do that again, because that's... I'm not a math genius. 15, 36. Oh. Oh, 30. Oh, no. 42. Gah. Got stuck. Anyway, so that's how so that's how repeat until works. It will repeat until the test has been satisfied. So, what's that one? Press a key marked. All right, that's testing your reflexes. It's testing the reflexes. Oh, let's try that, because my reflexes are rubbish. Now this is not going to work because it goes over a line, so we have to help it a little bit. There we go. Not wearing that t-shirt now. Not wearing it yet today. Right, let's see. Z, H, ooh, F, Y, I, U, W, R, Z, W. Go on. I'm slowing down. V, T, O, Gee, well that's going to carry on because there's no way I'm going to satisfy when the character equals 0, so when it comes with a 0 character. Oh, not enough of that one. But that shows you how the repeat until works. A really powerful instruction. We all know what a for next loop is. Standard for next loop, for x for variable equals start to finish in steps of whatever. So I don't know if people use steps. It's not popular, but you have to use a step if you want to go backwards. So if you say if x equals 20 to 8, you have to do step -1. If you did just left it with 4x equals 20 to 8, it would only run through it once. It wouldn't actually. Yes, he does. So now this is what I was waiting for. Someone spent serious time working this out. Right, so this is a demonstration of using nested for next loop. So we've got 4 rows, and then we've got stars, and then we've got stripes. So there's what? 1, 2, 2, 2, 3. So at the most there's 3 levels to that. And that does the stars and stripes. What was it? List 07, wasn't it? Was it list 07? Aha! It's not O, it's not 0, it's O. So we've got 3 levels, 4 levels there, innit? Oh no, it comes back. But we all know what a for next loop is. Oh look! And here it is. Right, list 0. List the program exactly as it's stored. Okay, list. List 1, list the program with 1 space after each line number. Okay. Oh, right, okay. Oh, the shortcuts. So list 07 tabs it. And oh, that doesn't put it back. No. And that put it back. Thank you. So we've finally found what it is. It's called listo. So 3 modes. We'll have to remember that when we look at the stuff. Right. Let's see what else can we find. So that's for next loop. So it's going through for. We know for next loops. If then else. Now this is something else that. Yeah, this CBM Basic doesn't have if then else, does it? No. So another uniqueness. I'm not sure if Sinclair Basic. Did it have if then else? Did it? I don't think it did. Well, it's certainly not on there. Where's if? No, I didn't think it did. Yeah, CBM Basic doesn't have it. Probably Spectrum Basic. Oh, no. That didn't have else. So something else unique to the BBC was the ability to do if something, do something, else do something else. Like here. If h is equal to x times 5, then do proc god, else do proc bad. I like BBC Basic. Right, here we go. Procedures. This was a big thing because you couldn't make procedures anywhere else, and I used them in my A-levels. Basically, it's a way of isolating a routine and having variables inside the procedure, but you don't see them outside, I don't think. You can send parameters in. I don't think you can get parameters back out. I'm not too sure. But then again, I know there is localization of parameters, of variables. But the beauty of this is you could name the procedure. So you could have, like here, proc intro, proc fire, proc score, and it allowed you to name the procedures. So you didn't have to remember about go sub 300 or go sub 500. And the beauty of this is if you had to renumber your program, you didn't have to worry about finding all the places where you was calling go sub 300, go sub 400, go sub 500, because you never know what it might have been done. And this was the basis of building, the precursor to function building, but it was just procedure building. So it basically, you built a procedure that you'd run many times, but you would just call it like this. So you'd end up with a small program at the start to do your processes. Now I did in my machine, in my project, there was a procedure that did the assembly, there was a procedure that did the bank account maths, there was a procedure that did all the there's several procedures that did all the disk activity, so there was disk write, disk read and all that. I don't think I used the go sub. I'll have to have a look, because I tried to use as much as the BBC basic language as I could, rather than just writing on my 64 and then converting it to the Beeb. But this was a big thing, that you could write procedures. You could separate your code into procedures that were not dependent on anything else. Oh, I'm not doing test my reactions again. No. What's this? Hypno. Let's have a look at this. Sorry. List. Right, run. Right. So what? So what is that doing? Mode 5, setting the viewport. So we've got a box and we're sending in X to the box. So where's box? Def box. Alright, so this is where it's drawing the box. So it's moving to the first point, then drawing to the second point, third point, fourth point, and then fifth point, and then finishing. So we've got a procedure in there that's just purely to draw the box, and we are sending in a variable that it uses internally. But I don't think this J could be accessed outside of the procedure. I don't think if you modified J, you couldn't use it outside. But I'm not too sure if it. I'm not too sure if we'd have to try it. Hang on. I'm not sure if yes, you can't. J is local, I thought it was. So if we modify J, it doesn't get passed back, does it? X will stay the same. Let's do that. See what it comes back. Oh, we'll see what it passes in first. That would help. So 89. Yeah. So that shows you that even though we changed J here, it doesn't get this variable is local to within the procedure. That's what I was thinking about. Shut up. So you can do whatever you wanted to J within the procedure, but it wouldn't affect the. So it doesn't pass the value back as a reference back into the original variable. And this local variables was I don't think that was anywhere else in any basic. Huh? This localization. Really? Okay. Okay. Could we see from any 250 241, could we actually see the variable from outside? Yes. So we could see global variables, but we couldn't see the local variable. We ain't got to the local command. What, like that? We ain't got to the local bit yet. But this is showing, this is not, this is saying that J's global because it's up there. Yeah, J's global because it's up there. So if we get rid of line 10. And then we run it now. That should be doing it. Oh, hang on. J's global because we're not passing it in. Ah, got ya. But if we did this, there we go. So that's a demonstration of how to use local variables. So we've got a local variable that we pass in, we add 10 to it, we print it out, but then that's it. And the reason why it's going 11, 12, 13, 14 is because that's what we're passing in. We're passing 1 to 5. So it's adding 10 to that number. Ah, here we go. So there, Mr. Knight was right. So you can make X local in here. So 72. So that's basically adding J divided by X. Yeah, we're not going to do that. But that just shows you that you can set a variable that's local that you can only see from within there. Right, functions. Now, you could do functions sort of in CVM. But you couldn't do functions like this. What, in CVM? It uses the stat, or this still uses the stat? Also, I don't think you could pass more than one variable in. I didn't think you could pass more than one variable in. Yeah, you can't. You can only pass X in, can't you? You can only pass one in. Oh, right. So the BBC, the 64 allowed you to write a function of sorts, but you could only pass one parameter through. But the BBC allows you to create a function and pass as many parameters as you can through. So this one's got 3, and what it's doing, it's saying it equals X plus Y plus Z. So we should be able to print that out. Just make life a bit easier. Help it with that. Right. Give me 3 numbers. Let's work this out. 3, 6, 9. So that's 18. There you go. Now you couldn't do that with a 64. You could only pass one number in. Which was a pain up the backside when you wanted to work out high-res graphics. What you would do, you'd create two functions. One for X, one for Y, and then it would work it out. Right. Go subs. Well, we know what go sub is. That's just like a JSR in assembly, but you're go subbing to the line number rather than a name. We have that in C64. Who, yeah, go tos. Yes. It was rammed in me at university. Never use a go-to. You should never ever need to use a go-to. Killed go-to for me. Right, this is new. We had this in Commodore Basic on go-to, but we didn't have this on go sub, which would have made life lots and lots easier, because then you could return back to where you went rather than having to go on go to and then figure out where you've got to go back to. Oh, that would have been great, that command. But it's in BBC Basic. They thought of that as well, to allow you to do subroutines that allowed you to return you back to where you was doing the on. Right, arrays, same as normal. As normal. Anything unique about arrays? No. Reading data, restore, same as 64. Could the BBC restore to a specific point? Could you restore to a specific point? I'm not too sure if it was. Yeah, I think you could restore to a line number, couldn't you? Yeah, as the Commodore, when you did restore, it restored it back to the beginning, but the BBC allowed you to restore to the line number. So if you had a massive data pool, and you knew that you had to read from a certain point again, you could restore back to that line number. As with the with the Commodore Basic, yeah, as with the Commodore Basic, when you did restore, you had to read all the bit you didn't want to get to the bit that you did want. See, some forward-thinking people. Who was responsible for BBC Basic? Was it Wilson? Oh, that's going to annoy me now. Yeah, Sophie Wilson. Yeah. She designed the ARM chip, didn't she? Yeah. Clever lady. So she wrote this basic. How forward thinking was she? Right, so is there a restore to a certain point around here? Does that demonstrate this? No. So where's the restore command? Data, blah blah blah. Aha, you will notice that line 50 use restore statement to reset the data pointer to either line 170 where the BL data is stored. Right, so we're looking for line 50, are we? There we go. So it's telling it to restore the data back to here. Now in this situation, that's the beginning of the data, but we could have easily put the restore to point to here, line 300, and missed reading all this lot. But you can't do that with Commodore Basic. Can't do that at all. You have to write a routine that reads it, wasting cycles. And some more commands that we haven't got in Basic. Yes, good for game-based tables. And also, what did I use it for? Ooh, I think I used it in that National COBOL program. Yeah. Other things that Commodores can't do. Div and mod. How many times have you wanted to be able to find the whole number and find the remainder of a divide instead of just getting the whole number? Give me the remainder. 11 mod 4 gives you 3 left over. Easy peasy. Not have to do, what is it? Int. So 11 divided by 4 integer. And then you do 11 minus the result to get your result. Ugh, get the remainder. Rubbish. Yeah, but these two commands should have been in there. How many times have I had to do work the whole number out minus the whole number from that just to get the remainder? Rubbish. Right, what else have we got? So that's talking. I mean, that's another thing. Tab. You could not tab lines. It was columns, wasn't it? What, tab? Oh, div and mod. Right, okay. I mean, tab for the Commodores. That just tabbed it over. I want to go down. I want to go down. BBC Basic allows you to do it. Tab X and Y. Point it at that position. Yeah. Yeah. So tab's another one. Oh look, there's a restore. Right, restoring back to that. What else we got? Have we got any? We've got functions in there. Work out the leap year. How does it work out the leap year? If year mod 4 equals 0 and year mod 100 is not equal to 0, or year mod 400 equals 0, then it's true. Else false. So if that is 4, if that's 4, if that equals 0 and that is true, so that will fail for any other one. So it doesn't matter about the 100-year mark and the 400-year mark. Who would have thought working out leap years was easy down to that? Anyway. Well, we know about left, we know about mid, and we know about right. Which is basically just taking portions of a string. Got in that, we know how to do that. What else we got? What are oh, this is still doing the tabs and all that, isn't it? The data reads. Use it to find keys. Well, we've done that because I did list, didn't I? So basically all that's doing is so star. Yep. Key 1 is list. And then I think it's that for return. So if I press F1 now, there we go. So you can define the F keys, and you couldn't do that in Commodore Basic. Why did they give you 4 function keys if you couldn't do anything with them? You could do something with them if I think you had the Programmer's Expansion System, Programmer's Aid, I think it was. You could define the function keys, but you can't do it out of the box. Ridiculous. So you could do all of them. It was a toy. Yeah. I mean, it was aimed at that, wasn't it? A games machine. Right, operators. Well, we know about all this lot. Now, did the 64 have power? I think it did, didn't it? Did the 64 have power? Power 2. Hang on. Where's me 64? Ooh, power. Where's power? Did it have... Right. You just did that. I can't find it. Oh, I'm not hunting for it. So now Commodore Basic couldn't do that. XOR. No, it couldn't do that. Should be there's AND. There's OR. There's no XOR. Look at that. Could do an XOR in BASIC. Who would have thought it? Shift 6. I did Shift 6. And I got that stupid thingy. I'm not hunting for it now, mate. Maybe so. Shift 6. This is Shift 6 for me. It's ampersand. Maybe my mapping's wrong. Never mind. So, Commodore Basic couldn't do that. That's another thing. What's all this grouping about? This version of BASIC has large numbers for operators and is very important that the user is aware of the order of the precedence. Oh, is that BODMAS? Yeah, it's BODMAS, isn't it? Yeah. Okay. Now I know what that is. Error handling. Oh. BIDMAS in this case, yeah. Error handling. Oh, God, dear. I don't believe it had any form of error handling. No. No. Now this, I know this for a fact, was nicked by Microsoft in QBasic, because that's how they did error handling in the first iterations of BASIC. So basically what it allows you to do is, right at the start of the program, you could put in on error go to this place. So it doesn't matter what the error is, just go to that place, right? And you could, halfway through your program, you could redefine it and say, on error, go to this place. But then you'd have to put it back if you had a master error trapping. And then what it did was it allowed you to print the has it got the error? Yeah, yes, there we are. Prints the error, and I bet it's got the line line number. So it allowed you to print the error and print the line number. On error, show blue screen of death. Mate, I wasn't coding in 1978 on BASIC, especially MS BASIC. But this should have been in Commodore BASIC. To be able to, the most common thing is divide. Oh, it's there. Divide by 0. It's just to trap divide by 0. You know, every now and then you do accidentally have a 0, and just be able to trap it and say, "Oh, I'm sorry, it's a 0. Right, carry on." So we'll be use that in your basic programs. On error, go to the error handler, and then you just make the error handler do what you want. Like you can trap the error. If it's 18 here, just do a print and then go back to 120. Oh, it traps escape as well. All right. Right, oh, Teletext Mode. Right, this is the mode that we've been messing around with a lot. This is Teletext Mode. This. Mode 7. Back in the day when dinosaurs ruled the earth and we had big CRTVs giving us massive doses of radiation, there was this little known thing called Teletext that occupied, I think it was the top set of scan lines in the TV signal that was out of sight of the TV picture, and in there they carried a lot of data that then could be decoded. And one of the things that the BBC Corporation wanted was the computer to be able to use that teletext as a data source, and so that's where Mode 7 came from. So this is how teletext used to be reflected on the TV. So you had different colours. There weren't many colours, but here we go. So let's do this. So the colours were characters, like in Commodore. There we go. So it prints ABC in white, then changes to red, and then it does DEF, and then changes to green. Why is there a greater than sign? Oh, I know. Got to help it out here. There we go. So it's just like the Commodore, where they've got characters that define to change the colour. So in Petsky you had a character to make it go red, blue. Well, the Acorn system did the same thing. And as you can see here, these are the colours that can be done. So, and then they had flashing colours. Ah, here you go. Make things flash. Let's grab that. There you go. So the word flasher is flashing, and that's just because of this character 136 makes the text flash. But they had other things as well. Yeah, background. You could set background colours. Oh, copy. Have to put that in there. Help it out a little bit. There we go. There you go. So we've got a yellow background with blue writing. There was ways of making this look like a teletyper as well. So blue letters on yellow, that's what we've done. That's the same as that. Double height characters, well we did that in assembly, but we can do this again. In fact, we'll change it to 141. Right, so we'll change this to 141. Oops. Oh, John, come on. Right. There you go. The problem is you have to print twice to make it do it. So at the moment we've only printed it once. So if we do this 30. Oh. There you go, there's your double height characters. So this is all the stuff you can, all the, oh, really, F0, right, okay, let's try it. F5, nope. Oh, shift F5, there we go. F6, what's that? F8, that should be flashing, and then F9 should put it back. My listings are full of this. But I've forgotten what the codes were, but now I know them, I can type them back in. I might do that, type it back in. Because I still ain't found the disc and my dad hasn't found it, so yeah. Star effects, oh, we'll get to that. We'll get to that. Right then, so, graphics, ooh. Graphics mode. Oops. Yeah. The BBC had basic set of block, like the PET, had a basic set of the 4-quadrant graphics. You know, so you had 4 quadrants, and you could have 16 different possible combinations for one character, and so you had the ability to plot on a Commodore PET. They called it high-res mode. Was it high-res mode? No, it wasn't. But it was a way of reflecting sort of high-res. You know, you could draw a line from there to there on an 80-column machine, and it looked like a line, but it was in block graphics. Well, the BBC has the same in Teletext Mode, which allows you to well, it looks like they are 6 quadrants. So they're saying it is possible to calculate the code for any particular graphic shape in the following way. Each of the 6 cells contributes a certain number to the total code. Alright then, let's try it, shall we? Yeah, okay. So if we want to say just do those three, so that's 1 plus 4 plus 16. 1 plus 4 plus 16. Plus 4 plus 16. Nope. Broke it. Broke it. Oh, have I got to put 145 in front of it? Rats. One plus 4 plus 16. No? Hmm. Two plus 8 plus...
Ladies and gentlemen, 6502 kebab has entered the chat. That is not going to get old. We have to put 128 in front of it. Okay. That was a listen. Okay. Oh, come on, John. Hit the right characters.
Oi, John, pay attention
Yes,
to chat.
yes, yes, yes. Like that. Yes. Didn't print it. One. Oh, 1 plus 4 plus... Ah, I've got the wrong number in there. Copy 4. Nope. Still not doing it.
Oi, John, pay attention to chat.
Just 128. Okay. It's possible to calculate the code for any particular graphic shape in the following way. Each of the 6 cells contributes a certain number to the total code. And in addition, you should add in 32 plus 128. Oh. Oh, okay. So 160 plus 1 plus 4 plus 16. Hey! Hooray! Thank you. Thank you. No, not quite, mate. What? I'll get you another one. So that means then we can, if we do this, so if we want to do that one and that one, so that's 1 plus 8 8 plus 16. So that should give us a... There you go. Yeah, it replaces the lowercase with graphics. So if we grab that and then carry on, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y. Woo.
Oi, John, pay attention to chat.
Yes, I know. I know. I know. Right. Let's see what that gives us. There you go. But there must be more characters because not every combination is there. But it, like I say, these characters were, these graphics, there's 32, yeah. Is it the numbers? There's what? No, the numbers won't be. We'll work it out. But these block characters, they used to make pictures in teletext. Hang on. So they used to make pictures like this. And these were all those block characters that were defined. Yeah? And they were very creative in some of the graphics they'd done, you know. God, they were the days. Information at your fingertips. All you had to do was press next. Oh, I've learnt something today. Making a larger slate. Elsewhere in the guide it shows you how to use user-defined characters to draw spaceships. Blah blah blah. Yeah, well we'll get to that. So this is 3, so basically it's doing that. So this is going to draw a spaceship. Using teletext graphics. Let's help it out a bit. Oh. You know what? One spaceship. These are BBC hardware sprites. Really? Hmm. Now this... Oh, hang on. Instead of using print X and Y, it's probably easier in this case to use ASCII codes to move the cursor down one line. Code 10 and back 4 spaces, code 8 4 times. It is probably also easier to use VDU statement rather than print character. If these two things are done, then the program becomes... Okay. Oh, right. So VDU is basically outputting a character. So we're outputting a character 146 here, and then 145, 1912, and that's what's been translated into that. Well, I did not know that. I thought it was something special. That makes that VDU command even more impressive. So what's this all about then? Anything more? Not local. We're getting there. Oh, proc. That's this bit here, isn't it? That needs help. Anything else? No. Now that is what I was talking about. That this is the sort of graphics that you could do on the Commodore PET using their 4-quadrant thing. And this is demonstrating it in the BBC using its 6 blocks on per character. That's pretty impressive. I don't know what all this is. I don't know what all that is. Right, here we go. It uses a lookup table called S% to remember the numbers corresponding to each of the 6 pixels pitch elements. Right. Must be it. I wonder if that's a table in memory. The lookup table must be set up at the beginning of the program. Yeah, byte array in memory. And then uses that here. It's very clever though, seeing as it's not in high res mode. Right, advanced graphics, here we go. The thing that the Commodore could not do. To plot a line. So we have mode which changes our screen. So in 64 terms we don't have a mode. It's either bitmap or not. G-color sets the colour of the lines, I think. Draw, self-explanatory. Move is where we're moving, because the BBC doesn't say draw from this point to this point. It says move to this point, then draw to this point, then draw to this point, then draw to that point. There's no draw from this point to this point, draw from this point to this point. Plot. Draw, which draws lines, dotted lines, points, and colours in triangles. Okay. VDU, well, we know what that is. That's... So we got the modes. Mode 0, 2 colours, BBC B only. Very high resolution, requires 20k of memory. Right, so if we go mode 0, is it free? For bytes free? What's the... How do you know how much memory you've got left? Alright. Ooh. A reserved integer. High mem. So that's the top of memory. Should return how much free memory you've got. Right, okay. Really? So out of all that, so as soon right, so out of all that, we've gone into super duper duper graphics mode with 2 colours, and we've only got 5k left to play with. Right, okay. Right, let's copy that in. Let's try the other modes. Right, so what does mode 1 give us? How much free space then? Only 5. Is that right? Oh yeah. Mode 1 has 4 colours, requires 20k of memory. Well, that just makes it even more impressive elite. Because that was mode 0, wasn't it? And mode 1. Let's try mode 2. Mode 2. Oh, another 16k. Another 20k. So mode 0, 1 and 2 use 20k of the memory.
Oi, John, pay attention to chat.
Put it in F1. Okay. I don't think it'll paste in. No, didn't think it would. Right. Well, I forgot what it was. Is it comma? I forgot what it was. Let's go back. Yeah. Test failed. I forgot what it was. Hang on. Let's put it back. BBC Basic. Thank you. Right. There's no comma. There we go. F1. Let's Better? Right. Thank you. Let's go back to the advanced graphics, which is around here. Right, so we've done mode 2, mode 3. So this is same as mode 1, but it only uses... What's the difference between mode 0 and mode 1? Mode 3. Oh, text only. But it still uses 16K. Oh, it can only fit in 16K. Okay. Mode 4. There we go. 2 colours, high resolution, text 10K. Mode 5 is 4 colours, I think. And mode 6 is just text only. High res, yeah. Mode 5. That is VIC 20 graphics. And mode 7 gives you the maximum. So 24K out of 32. Oh, Mikroman. You've just missed an epic fail. Right, so drawing lines. As I said before, we'll do mode 5 like it is here. You move to a point. Yeah. So now we've moved to 400 and 400, which should be somewhere around here. And we're going to draw from 400, 400 to 800, 400. There you go. And then we're going to draw, so it's currently at 800, 400. So we're going to draw 400, 800. And then draw 400, 400. Yeah. So that's how the drawing works. You draw to a point from where you are. You don't say you start here and you finish here. So what we'll do is we'll CLS that, mode 7. We'll copy this in and see what these guys are going to be playing at. So it's drawing a triangle. We've just done that, but we did it by hand. So run. Now that draws a square. Oh, I know why, because I forgot that one, didn't I? Now they're going to put this in. So what's that going to do? Make it red. Right, the normal foreground colour modified is white. Add the following line. This changes the lines to logical colour 1, which in mode 5 is red. Mode 5 has only 4 colours, so we can redefine the 4 colours. When the machine is switched on, they are black, red, yellow and white. However, logical colours can be changed by using the VDU command. How to fill your plot. Okay. So this is going to do a plot fill, is it? Nice. And then the second half. So plot 85 is a fill. How to change the colours. In particular moments the computer... The number of colours can appear on the screen. Oh, there's mode 0, 1, 3, 5. And only has 2 colours. Okay. However, change the colour for a drawing. So that's black, red, yellow, white. So let's do yellow. 2. There we go. You will have noticed so far 1 represents red, 2 yellow, and so on. To change the background colour, you add 128. Okay. So list. You add 128. Right, so 130. Okay. Oh, okay. Oh, it's done it there, isn't it? What's CLS at there? Ah, there we go. Well done, mate. Thank you. Thank you, mate. Yeah. You have to get used to the fact that to make the background change, you've got a clear screen. It's not like the 64 where you change the background, it instantly changes. You don't have to do anything. I keep forgetting about that. But that's how we change, how we plot in high res mode. Yeah, it's, you have to, because if we change it to 129, so that's background is red now. It only does the bits it draws, yeah? So to make the whole background you have to do CLS. It's not like the 64 where you could poke the background colour and it instantly changes. And yeah. In two colour modes, such as mode 4, we can do the similar thing. VDU19 changes the logical foreground colour 1, which is literally white, to actual colour 2, which is green. Okay, let's try it. So VDU 19, 1, 2, 1, 2, 3. Bingo! So even though this mode is only 2 colours, you know, white and black, you can redefine. So let's redefine the black. So it's VDU 19, black to 5. So what's that going to do? Oh, dangerous. Oh, that is dangerous. Oh, hang on. What's white? Ah, mode 7. That's it. So what? Ah, here's the colours. So if we do the same thing again, mode 4, and we do VDU19, change the black to be that colour. There we go, and then it was VDU 19,1, 3, that is what the BBC Micro program used to be. Yeah, that's what I was trying to get. So VDU 19, 1, no, black, 4. Oh no. Oh, was it mode 6? Zero, 4, 1, 2, 3. There we go. That's it. The BBC Micro computer program. That's how they had the listings on the screen, wasn't it? So when you did list, it came out like that. I don't know if any of you guys have ever seen it. Hang on, let's see if we can find it. Here we go. It's this one, wasn't it? The owl. Here we go. Can you hear anything? Oh, here we go.
Good morning, sir. Oh, good morning. What do you have in mind?
Well, I don't know very much about computers. Perhaps you could give me some advice.
Well, there's the apple, the acorn, the pear.
Banana?
We have no bananas. We do have tangerines.
What's all this green grocery got to do with computers?
You know what it says in the Bible? Be fruitful and multiply.
I really wanted something electronic.
Disc or cassette.
No, not hi-fi.
You know, you'd be happy with a pen.
Did he?
I have really set my heart on a computer.
You want to try watching the new TV series? The computer.
Look at that. Common pet in the bottom.
Computer that goes with it.
Oh, that's... Have you got one in blue?
You don't know much about computers, do you, sir?
No, but I know what I like.
Look at the pet in the bottom.
Well, the world of computers can seem a very unfriendly jungle to the uninitiated. It doesn't have to be like that. During the course of this series, one of the things I should be doing is finding out what ordinary people, non-experts like you and I, need to know about what they call information technology. One thing I know already, the computer revolution isn't happening tomorrow. It's happening now.
Just tell it to run. Nice simple English words, huh?
Oh, this is where he gets him.
Yeah, it'll take half a minute, so that
He
will
used to
take
type stuff in.
no time at all.
Now, how do we know it's finished?
Well, we've got the symbol back here, and that shows the computer's waiting for you to do your next thing.
So that's in there.
That's it. So we can switch it off.
Go on then, what's next? What do we have to do next? Go on.
What was on there is in there now.
Happily, yes. All you have to do is to tap out list and tell you what's in it.
List, L-I-S-T.
Alliance team. Retired.
Wow. Okay, that's
And
the
that's
very
what it's doing from that episode.
Right. Okay, well we know it's in there. How do we play the game?
Just tell it to run.
Nice simple English words, I must say. And return, I
That's
suppose.
it. You should be in the game. It works.
Right, war game. Move the bat. Left with the Z key.
Oh, Acanoids.
That's a simple bit of play. Okay, well obviously it's not just for playing games. It's a
Anyway, 1982. But in later ones, they had the screen looking like that, not like Mode 7. They had it looking like that. So it looked like a teletype I think. Anyway, right, so we know what VDU19 is. What's next? Yeah, I watched it as well. But because the problem was, because it was the BBC and we had a Commodore 64. Yeah, we had to try and convert. Which, when you didn't understand the BBC basic language because you'd never touched one before, was a little bit tricky. So these are the colours, numbers that you can set for the different modes. So mode 2, flashing red with cyan. Wow. Zero comma 137 comma 00. What's the other one? 40. Yeah. Right. What else? So this is all the different different colours we can have. Ooh. Yeah, okay. Animation. How to make a ball move on the screen. This will right. Okay. Copy that. Copy that. That. No, I'm not. Right, okay. Well, it's there. It's a tiny ball. So they would change line 50 to speed it up. Step 10. There we go. I'm really torturing the audience today. Well, I mean, we'll get to the good stuff. The problem is you have to learn all these things like VDU23. That is making a character. Right? Mode 3. There we go. So that's saying redefine 240. So if we do print, that should print that little man. There you go. Now you can't do that on the VIT, on the 64. As simple as that. The amount of faff you have to go through. That's something that, these are the things that should have been in the 64 to make it easier. The ability to do all that instead of having buying cartridges. Oh, the flashing. Oh, sorry. So we could make our little man walk across the screen. I think that's what that's doing, isn't it? Yeah, I think that's what that's doing. So if we go new, grab that. And grab that. That should make the little man walk across the screen. There we go. Now we did a rocket. That looks like the end of High State Building. Don't look like a rocket. But because we did a rocket in standard graphics, we can do the same in using VDU23, and this is what we'll do here. Right, let's just make this a bit easier. That to do. Oh, and that one as well. There you go. One Empire State Building. That's an Empire State Building. That's not a rocket. Could have made a better job than that. And what's this doing? SpaceX, yeah. To make it take off, change the program by adding this. Okay. So it should take off. There we go. Oh, isn't the small things wonderful? Now add an extra character to produce the flash at the bottom of the screen. Okay. So we're going to add that to the program. There we go. See, we redefined 4 characters in 4 lines, and it was there straight away, and we didn't have to mess around with setting up memory addressing and stuff like that. Absolutely ridiculous. Right. What's this? Pocket rocket. Is that this one here? Yeah. X20. Oh, VDU5. Okay. So, oh, no. Need to help it out. Turn off the cursor. Wait for a while. Is that it? Now that's a rocket taking off. I like how it gets rid of the flames after a while. That's a nice little touch. But there you go. We redefined 4 characters in 4 lines just by using this VDU23. So when you come to writing basic programs, you can redefine a character just using VDU23 and it's done. No messing around with VIC chip addressing and stuff like that. It's ridiculous. Right. What's this? Making a complete lunar lander game. Really? Oh, we've got to do this. Neptune lander, here we come. Right, let's help this out. Let's copy that. I don't think that's crossing any lines. No, that's done it. Okay, let's do this lot. Help this out because it's crossing lines. There we go. That. That. That looks like we've got line numbers on each line. What else we got to do? This. This, wow. Grab that. Right, I've got to make sure there's a line number at the start of each line. So I've got to make that, this, that, this. Right, that's done all of that. Right, grab this lot. Make sure there's a line number at the start of each line. Right, should be it. Running the game, you start off at a height of 46 miles, moving at 1 mile a second or 3,600 miles an hour. You have fuel of 16,000 pounds and your weight, and you weight to start with, including fuel, is 33,000 pounds. You fire the rockets by pressing one of the keys 1 to 9 and holding it down until you want to stop burn. The rate of burn is proportional to the number. Okay. Lunar lander, here we come. Well, that didn't work, did it? Because that stopped. Let's have a look. Must have a bug. Let's do it again. We don't need that. So list to 110. Nope. There we go. So that looks okay. Proc moon, proc initialize, video 5, repeat. In fact, that will help. Right, there we go, that'll help. Burn is that, star FX 1. There's no comma. I'm just wondering if there's meant to be a comma there. burn equals burn times 30. Calculate old. Y old minus 4. Rocket proc burn until height equals 0. If speed is less than greater than that, proc crash, else proc fanfare. Yep, that looks okay. So list 700 to 870. Proc leg rules, proc end, proc moon. 2 on move X, naught, plot 85, X. That looks okay. So we'll do it in sections. So we'll do 900. 1100. Initialize times 0. Speed is equal to 0. 46. Y. Old Y. Gravity is that. Fuel is that. Burn rate. N proc. Define. Calculate. If you... Ooh. Well, define calculates there. We've got some extra code in there somewhere. That's from him, isn't it? Did I not initialize it? Oh, really? Oh, we'll do it again. Let's do it again. I also think that should be all like that. Mode 5, blah 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 blah. Right, prop label. I think that should be 1. Else, then else. Right, 250, 700 to 800. Put that in there. 700. All right. 900. We'll go to 1200. It's alright, it's alright, it's alright. And there's that, that. Right, 1200. $5020. Grab that. Turn that. Yeah, you do need it with the comment. So this is wrong. You know, this is wrong where they've got the because they've got the comma there, but then they haven't got the comma there, so they've not quite copied it like for like. Anyway, no, you don't need spaces. It's like the C64. You don't need to have spaces. It just makes it readable, like Andy says. So we should have a line number on every line. Right. select all, copy, new, paste. Right, let's see if we get anything. No such variable. Oh. No such variable where? What line number? Yeah. But we're struggling now. I don't even see a line number.
Oi, John, pay attention to chat.
Yeah. Good point. 1140. Thank you, mate. Height equals height minus speed times burn time. Ooh. I wonder if it's this. I wonder if there's another. I give 5, mate. Hey, WauloK. Welcome. I think there's supposed to be a 1140. Hang on. You're not in my list, mate. Oh, I'll give you some. There you go. Welcome. Ooh. I could rename it AMP points, couldn't I? But it's all database driven now. I've got rid of the JSON file. Right, let's find out. Where are we? Line 1140. Height times speed minus burn time. So height minus speed times burn time minus. There's a minus missing. Minus. Right, let's see, does it run now? Ugh. Oh. Ooh, 1150. Speed equals speed burn time times gravity minus. Oh. Minus. Right, see. There we go. Cool. This speed's not slowing down, is it? Come on. Gonna crash. Gonna crash. I have no idea. I don't think this is working. I don't think it's working. I don't think it's working. Look. I'm going up. My speed is minus, so I'm going up. Ah, typing games. Hey, who thought of them? Ah. Let's save this. What should we do? Okay. Where am I? What have I got? No. Discs. Right, so I've got something in drive notes. So drive 1. There's nothing in there. So I could what am I looking for? Denew, that's it. So we got 400, 401, 402, 403, right. Star denew 404. Bad drive. Four. Disk not formatted. I don't want 404. Yeah. I'm trying to right, deform. Deform 404. Oh, rats. I want to save it. See, 404 ain't there. I haven't got anything in drive 1, so I should be able to format it. Deform 44. Okay. Yeah, hang on, I've got the instructions somewhere. May do, don't know yet. Spinel. Let's have a look. Don't want to use FF. Go on, give me the bog standard stuff. Right. Alright. See you later, mate. Night, mate. Right, it's up at the top. It's got to be. D in. Oh, I've forgotten how to use it. Right. That says drive. D-new drive. Right. Drive 1. D-new 1. Oh, okay. Let's do that. Right. Need to mount a disk. Need to mount a disk. Have I got an empty disk? That'll do. Oh, read only. What? Yeah. How do I not make it read only? So that's not read only. Let's make a new disk and we'll put it in here. Right. Disk is read only. Ugh. There we go. Yeah, check the notch. That's it, we've saved it now. So we've got our own disk. Maybe that's what was wrong with Turbo MMC. It's because this was set to write protect. Right, we saved that. So that game was rubbish. So sound. Channel number, amplitude, so that's volume, pitch, and how long for. Okay. Did you hear anything? I didn't. Maybe sound's not on. Oh, have we got sound on here? I'll have to figure out how to get the sound going. I'll have to figure out how to get the sound going.
Beep them text to speech output enabled.
Well, how to use it?
Beep them text to speech output enabled.
Right. Before I go, I want to show you how you can set up how to develop on here. So, VS Code. And what you need is spit something. You need a piece of software called Beeb Assembler. So Beeb ASM, and you can get it from here. It's free. So this is the GitHub with the source code and all that, so you can see how they've made it and stuff. But there it is, Beeb Assembler, and you'll need a Beeb emulator. So, oh, that's the competition, isn't it? Yep, that's the competition. I don't know. Can you publish it? What's it need? Beeb Assembly is distributed with source code. Should be able to easily portable to any platform you wish. Just build under to build under Windows, you will need Mini GW, and most you probably can build this on the Mac, because the source is there, and if it's in C++, it is, and there's a make file. You should be able to build it on the Mac, mate. Have a go, see if you can build it on the Mac. Well, has it got releases? Has it got releases? No. But it's got all the instructions to use the assembler, yeah? See if you can build it on the Mac, mate. If it's all there, you should be able to build it. So, in VS Code, let me open... where's my... the one I did, the test one. Here it is. So what you do, there's a BBC extension for VS Code. Let me find it. Might have gone past it. Yeah, gone past it. There we go, it's there. Called the Beeb VSC. So this is the BBC's development extension for the Visual Studio Code. And like it says, you need Beeb Assembler, which takes you to here. Yeah. I wonder if he's done it for others. No, he hasn't. And you also need BBC Emulator. So once you've installed it, then you've got to configure it, right? So to configure it, settings, and what you do, you just tell it where your assembler is, and you tell it where the emulator is, right? But it's not as easy as Kit to use, because you cannot use there isn't a standard function key. So what you do, you have to write some tasks, right? And so here I've got a task that allows me to build. So this is to build, yeah, build the SSD with the programming, and then there's a task that allows me to run it in the emulator. So you've got two tasks to run. Alright, so here is some, let's find the, that's it, that's the extension. Here's some machine code, and basically these are labels. We're telling it where to assemble to, and then we define our labels with ... like well, not like, but that's how you define a label. Dot, and then the name is a label, and then you've got the way to set text up, and then the last thing is the line that allows you to create the SSD. So this is saying save this as main from the start to the end, and the start is there and the end is there. So what you do is you do Control Shift P, run a task. It will say what task, and I want to, build it. There you go, it's built it, and now the SSD. So let me just delete that, so I can build it again for you. So highlight it, Control Shift P, run task, and build. We should get an SSD. There we go. And then do it again, Control Shift P, run task, and then you run it in the emulator. So you click it, and there you go. It runs it in the emulator. Now this is not running it properly because I did not save my configuration. Let me just put it back to what it was. save, because it doesn't work with Turbo MMC. Right, so Control-Shift-P, run task, run in emulator. There you go, hello world. And that's how you can develop on a modern day system inside the BBC Micro. It's a little bit tricky, a little bit faff, but what I'm going to do is I'm going to put this project on my GitHub as a template, yeah? So you'll be able to download it, load it in VS Code, as long as you've got the extension Beeb emulator and Beeb assembler, you'll be able to write or assemble and execute this hello world. And this is what we're going to be doing when we start doing our machine code, dedicated machine code projects. We're going to be using this. We're going to tinker with machine code in BASIC, but ultimately we want to be able to write the entire thing in machine code and not take any memory up just because of the basic element. Yeah, and the beauty of this is that, you know, if I load the file, here we go. So if I load the SSD that I've just created, there you go. It's done it. It's done the boot, and that's why it's run straight away. And what it does, it just says star basic and then star run main, and that allows then it to run the main and to run it straight away in here. Because when you do list, you don't see anything because the emulate the machine code has been put at 2000, and then that's how it's run. So I've got another one here. Let's see what that does. Control-Shift-P, run task, build it, then Control-Shift-P, run task, run. Oh, that's just hello world as well. Must be a different way of doing it. Oh yeah, it's using zero page. See what they look like. So this is 2. Yeah, I'm using zero page. I'm using the mods and stuff. Oh, the fact that you can make a statement be share lines using the colon. That's what I was messing around with. So this is going to be put in GitHub, and it's going to be put in the public version because it's a template and I want people to play with it. But like I say, VS Code, the extension is Beeb VSC, this one. There's only 2 properties. There's only 2 properties. Oh dear. You're showing your age now, mate. 2 properties. It's basically to tell it where your assembler is and where the emulator is. Now, we don't talk about him over here. Yeah, Mikroman, I'm just trying to explain the development environment for the BBC, right? So you need this extension. So you need Beeb VSC. You also need the Beeb assembler, where you can get from this link. You've got Beeb emulator. There are two settings in the extension, and that's basically where the assembler is and where your emulator is. And then you just write program, assembly program, like that. So I'm going to put this in my public GitHub, so as a template to start developing in machine code on the BBC emulator. And like I say, the beauty about it is it produces an SSD, so you can load it into a full fat BBC if you want. you know, by using a turbo MMC. I would mount that onto a turbo MMC and just use it. What is the binary format for the BBC? It's binary? I don't understand the question, mate. But like I say, the emulator has got, the assembler has got a very in-depth README. Oh. No, this is different. I've been trying to decipher it. So this is I mean A916, I think that's the first 2 bytes. Hang on. Yeah, A916, that's 22, isn't it? 16 plus 6, yeah. So A916, and then it's got JSR FFEE, yeah. So it's just straight, and then a terminating 0. So there's no actual load address there. So there must be. Oh, here it is. It's in the catalog. It's in the disk catalog. Look. So the load address and the execution address and how big it is. So the file itself doesn't have the load address in. Here in the disk, in the catalog of the disk, you know, the directory. So there's my main program, which is this, and it's got the load address here, the execution address, which is the same, and how big it is, and that's how it knows. So if you want to try, like I say, download that. Oh, you got some lag, okay. Do the Beeb assembler. Like I say, it's got a very comprehensive README. You know, all the different syntaxes, the directives, all the commands for the assembler, which you don't need to worry about because the extension does that for you. All the different functions that you can use inside the assembler, some constants, time formatting, and then you've got the assembler directives. So it's a bit different than Kick, but it will allow you to develop. I mean, this. No, that's a copy function. There was a hello world, I think. Anyway, so that's the assembler. I'm sure you should be able to assemble this, Andy, onto the Mac. It's C++, and the fact it's got a make file should allow you to do it. And I'll put my template. I'll put this template into GitHub on the public thing. So you should be able to grab it and set the. I mean, I've not put the assembler and the thing, but you can specify where the assembler and the emulator comes in here. But I've done it globally, so it's. I'm using a workspace because if you don't use a workspace, Kick Assembler tends to take over and ruin everything for you. So So at the moment in this workspace, you'll see that Kick Assembler is actually disabled for the workspace. Yep, Kick Assembler is disabled for the workspace, so it doesn't get in the way of the extension for the BBC. So I will where are we up to? Well, oh, sound. That's where we got stuck on. I'll try and find out why the emulator's not doing the sound. Maybe I've got to do an envelope, I don't know. Let's try it. There's a missing comma. Where? Yeah. Just don't know why that's not doing it. Oh, there you go. Right, so we're up to sound, and we'll try and figure out how this works. So this is what we're going to start the next video. But I just want to show you what I've worked out in when we come to writing machine code on the Beeb. There is a way of doing it in VS Code. It's there, it works. So if anybody has a problem, let me know. I'll put this project in GitHub as a template, as a tester, to see if you can get up and running. Well, I hope you found this interesting. I'm loving getting back into this. And eventually we are going to start, we'll start coding in BASIC, see if we can make a better lunar lander game than that one. Alright, so thanks guys, and I will, let's see, is anybody online? I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.